started the video lecture for the 22nd. So we're 1 week in to sprint 4. We'll have 1 week, 2 week, and then you drop sprint 4 at that Sunday night. And then we have that final exam. That'll be like an hour. So here are the deliverables. They look exactly the same if you just go into project deliverables here and just click on this example posting. It just looks like this. So these are all the aspects of my project going from sprint 3 to sprint 4. It looks just like this, that link that's there. I'll go through what all these parts are about, and where was I? Sprint 4 deliverables. And I'm going to ask you to do all this work, which basically I'm going through every week. This week will be heavy with like I'm fixing all the code, and so the UI completely works, all the prefabs work. And then I saved for next week this like new feature, randomizing the spawn types and randomizing the spawn times. That'll be for next week. So about an hour lecture this week, an hour next week, probably less next week because it's just how to randomize these two aspects. It'll probably be like a 45-minute lecture. I'm keeping it rather light because this week the code's a little complicated to wrap up, and so next week the code will be rather light. And then at the same time, remember, you're just kind of refreshing on the final review. So the final exam topics, which, let's see, sprint 4. Okay, get rid of that. Here's the final exam topics. So before I get to that, sprint 4 project deliverables, here's my example posting. I'm just explaining all the parts, right? And then I have my link. So I want you to do the same. I'm not doing user flows this sprint because it's mostly just cleaning. It's no new features. No. I want you to follow along with me. I want you to get your UI completely connected, working well, no bugs, nothing broken. Your prefabs work. They all have 3 animations. And these are the features that I'm working on. But it's all, like, for example, last week I did that UI script, how to animate the UI coming in and out. Making sure that the hide button's disabled during the animations. Cleaning up the UI into recognizable areas so it's really easier for a user to understand what is going on. Fixing up all the scripting issues, any bugs, all the elements of UI actually work with all the prefabs. Hotkeying 1 to 3 and 4 to 6 to quickly jump between prefabs and their animations. And then posting up your link, showing me your build, and then writing a little description. This is what I did. This is for sprint 4, blah, blah, blah. So when the TA looks at it, he can understand what you did, because some projects are deviating off of mine. So be like, well, you know, I've had issues here. I cleaned up this. And then this is something that's new. Yes, I'm not asking for user flows. What I'm asking is find 2 parts of your code that you're particularly interested in, that you're really happy that you solved something challenging. Take a screenshot of it, post that image up, and then explain to me your code. So you're following along with me. I'm just cleaning up everything. So now at the end, we're basically going through this refactoring phase. We're cleaning up, we're wrapping up the semester. It's like you're wrapping up your drop point. If you were like a freelance developer, you're dropping off your project. Now, instead of the user flows, take an image of your code, talk about what you fixed, what you cleaned, or what you did, what you're happy about. Just explain the code. Take another screenshot of another part of the code. Just explain it. I just want to see if you can explain your own code. So if I get 2 students with the same screenshots and the same code description, I know that you're just copying with each other. So it's just another safety check. It's like, can you actually explain 2 parts of the code to me? Anything, any part you're super interested in that you're like, wow, that was driving me crazy. I fixed it. I wish to talk about it. So a screenshot is a JPEG, a PNG, an image file that actually can show in the Moodle posting, and then talk about the code. Screenshot, talk. Here's the link to my build. You're good. So for this week, I am going to get the UI completely fixed. And then next week, basically, I'm just going to talk about this little area right here, randomizing these two parts. Yeah, because it's actually not, since we got this far along, if you can get through this week, that the randomizing those last two parts, it's not a big issue. It's the same little, create a Boolean, connect it to a little part of your code, do a check, should I randomize or not.
We don't have any online lectures.
This is, right, yeah, it's just this lecture. So I slowed down this last sprint where it's just weekly lectures. It's not a double one-to-one because it's like start studying for you. Finally, you push through. If you push through this far and you didn't drop out, then you're solid. Like, let's wrap it up. Let's return back to what your fundamentals are. Let's look at this stuff, these final exam topics. Let's do some quick little reviews. Now you have some extra time every week. If you need to be like, oh wait, what was going on with physics and raycasting? Go back in there, watch some videos. Or what was going on with animation? How to connect animations to animator? Go in there, watch some videos. Right? So use that extra time each week to just rehash what happened this semester and just wrap it up. Okay, so for this week, I got to fix some of the prefabs. I'm going to fix my color and speed methods. I have to introduce the fact that I'm actually going to record information onto the prefab. They're going to be a little bit smarter. They're going to be aware of what their color and their speed information is when they're first created, so that this will help me fix aspects of my UI. And I'm going to just fix some bugs. And then next week, I'll do these two random features. And so your project should look something similar to this, or be have this many features showing and connected to your paint strokes, and everything on your user interface is clean. It works. Like, I'm going to go over stress testing, just slamming buttons and nothing's going to break, and it still just paints, or it does whatever it's supposed to do. It's not going to crash on me. All right, so here we are, a week into sprint 4. We got another 2 weeks. You do your drop on the 5th, Sunday night. The drop is like this, besides you showing your screenshots of your code and explaining parts of your code and your little link to your build. This is what my build looks like. You can check it out right now. And then you come in for the final exam. So at the end of this class, I'm just going to cover a little bit more of the final exam, like for 10 minutes. I'm just going to go through and talk and be like, you should be aware of this. Remember we did that and what this is about. But the majority of this class is talking about getting this project bug-free at this point. All right, so if there's any questions, I'm just going to go over where the project's currently at, what I got to cover for the week. So when I click play and I'm running in the editor, this is exactly the build that's up on that link that's running on WebGL. So the only situation is this is not running in the editor. So when you first click play, and if I play it, the UI slides out. Because I had that little snippet of code that says if you're not running in the editor, do this little slide out. But this is the same. So yeah, we have a little script on the UI. We can push it aside. We can paint everywhere, and we can push it back. So if I turn off spawn time, and I just spawn one paint stroke, another one, and another one. So the size works on all of them, and I'm gonna have to fix this prefab. I'll get into it in this class, but notice I can just go to town on my size slider. It's fine. My glow slider, it's fine. It keeps the same color information. Opacity, so let me pull off glow, and here's what the object looks like. I'll just put a little glow because the sun's a little low. But notice I can play with the opacity of this object. It's fine. I can pull the blue out, the green out, even the red out. No color, and I can come back, and it remembers all of its color information. If you remember last time, sometimes these were broken. The color wouldn't update. And if you pull out like all of the color, it's just done. Like I come back, and now it's like all white. It's all black. It actually remembers its initial color information, and these are just relative changes off of it. So notice I go to 1 to 100. I don't go full to 0. And I'm going to show you how I'm recording this color information and how I change my scripts. But see, everything opaque, glow, any of these color changes, they come back, they're fine. So this whole part of the UI completely works for all of my prefabs. I stress tested it just there. It's all fine. I could do the speed. Speed's fine. Change the animation type. They all change. We're all good to go. It's all good. If you did other stuff for the previous sprints, don't worry about it. This is more like whatever I mess with on your UI, it works. Everything updates. We're good to go. So let me clear this stuff out, and I can start to randomize stuff. So if I randomize the speed and the animation type, this guy's a little complicated. Let me clear that out. Let me switch back to this one. It's a little easier to see. So they're all doing different things at different speeds. And if I mess with the speed slider and let it go, notice how they're all doing the same relative speed and the exact same animation, but it's just sped up ×2. So I'm remembering my initial animation speed, and now the slider is just like a multiplier. That's why it says X after it. So even at a very slow thing, they're all doing different speeds. And all their different animation states are differently. But if I turn off, okay, don't do different animation types. Let's do different animation speeds. And even when I zero it out and bring it back, they're still at that same relative animation speed. So this is going to be an important concept. I'm going to go over this. What else could I do? And you see, if I randomize the type, I'm getting all different spawn types. And I can randomize the time. So let's just make it simple. Let's just turn on time destroy. So we're going to randomize it and just do one spawn type. Notice they're all disappearing at different intervals. My paint stroke is like disappearing at different parts. And I can turn them all on, and I can just mess around with the speed, and it still is fine. So everything's good. All right. So I can slam on anything here, just mash these buttons, and it works. You got to do that with your own UI. So the only visual update to the UI is, yeah, I put little white boxes here, and then I just lowered their opacity, so they're kind of like little labels. So if I zoom out and click on one, there's text. Yeah, that's okay. Whatever I've clicked here, image animation. It's just white with the opacity lowered down so that the color behind it comes through. That's it. And then I showed you last week how I just duplicate these images and resize them, and they're just little color sections. And I just brought back this section, which last week I turned it off. But if you know how to build this, which was in last week's video, you can just build this. It's just connecting to different scripts. And these scripts I'm going to cover next week. All right. So some fixes I had to do. The cube prefab. All right. So actually I have them sitting up here. So notice I have the prefabs sitting here, and I can just turn them on. They're hidden, so it's very easy for me to show you. So I have 3 prefabs. I placed them on the scene so I can look at their relative sizing too and adjust them accordingly, so that I'll move this one here. Make sure that they're all kind of sized the same. So what I had to do is I seemed to settle on this convention where we could have, each prefab could have like 1 to many renderable objects underneath it, depending on how complex this painted object looks. Some people went with like snowflakes and just crazy shapes that had maybe 6, 8, 9, 10 rendered objects underneath it. And so, sure, we went with this convention. The parent of the prefab, it's got a name that's easy to understand. It's going to have a transform. It's going to have an animator. And I'm going to get to this later. We can ignore this data. But we have a transform and an animator. And underneath it, we have multiple objects. Each object has a renderable component and this collider, so that we know if we click on it, right click on it, we destroy it. It's got this shader that controls the color information. And so we have multiple objects, unknown numbers usually, because each paint stroke can have different numbers. This one has 3, this one has 3, but this one has 1. And I rebuilt it. If you remember last week, the render and the box collider was all up in the root. So if I bring in the old version, I think it was cube animated. Notice how cube animated, there's no arrow, there's nothing underneath it. I have my transform, my renderer, my collider, my animator, and my shader. Ignore this, we'll get to that later. And my shader, all up in the root, right? So now the structure is a little different than the others. So I basically rebuilt this one to be aligned with multiple object prefabs. So for example, the animator transform at the root, and there's only one child, just this cube, and I can animate on that. But the benefit of that now is if I play like a scaling animation, I can still grab the root. Even though this thing is playing this scaling animation, I can still modify the root, which the UI slider is going to do. So the size slider can still impact this prefab even though I'm animating on the scale, because I'm animating on the children's scale, the child object scale. Because you can only, remember, a parameter, a variable can only be manipulated via code or via the animation system. Behind the scenes, the animation system is doing it by code, but it like locks it down. It's like, nope, the animation system has a handle on this, so now my slider is broken because the slider is trying to directly change that variable by code. The variable being these scaling attributes, x, y, and z, of the parent transform. So if I go into click detector, and instead of cube animated 02, I do cube animated, and if I turn these off, these instances only exist in my scene to help me update them quickly. They're not meant to be there during playable mode. If I turn off time destroy, let's just ignore the fact that the animation is broken on it. But if I try to mess with the size, oh, it's because the animation is broken. So let me create cube animated. Let me actually he had the old. Let me just create a new animation real quick because I overwritten it. So actually cube bounce, I think that'll work. Cube bounce. Let me connect cube bounce to it. Okay, that's his old animation. Let me bring it back. Let me hide that. Alright, so that's my old cube. Oop, time destroy, gotta turn that off. This was the old prefab version, and notice it doesn't get impacted by the size. And that's because in the old way it was built, cube animated, the renderer was right at the root. So I can only grab this with code or with animation. So I basically rebuilt it. It's exactly the same, it functions the same, it runs the same animation style. But now there's a child that has the render information. So everything functions the same. It's just I rebuilt the prefab to have this child. So how did I do that? So cube animated, there's a few different ways to do it. One way I could say is game object create empty, and I'll name it as my new animated cube version 2 or whatever. Let me just bring it up here so that it's sitting right next to it. All right, and I could drag this. First, let me zero out its position so they're sitting at the same spot. Drag this underneath it, and I can just copy its animator. What was that? Oh, the original, the old version, which has the transform, the renderer, the collider, the animator, and the shader on it. I just dragged it underneath basically its new parent. And I called that parent like animated cube version 2 or something else. So all of this information is great underneath the child. It's just the animator needs to move up, because by convention I have all my animators at the root. So I can just take the animator, take this little gear, click copy component, and I can just paste it at the root. Yeah, it was the empty game object, which just had a transform. Now it's got an animator on it. So see, I'm rebuilding this prefab to have two parts: the root, the parent, and the child, as opposed to just if I bring back another version of cube animated. Here's the original cube animated. Here's where eventually I got to, where it's cube animated 2 with its child. So I went down to the child. Let me remove it. I'm going to remove it from the parent. I'm going to go to the child and just copy it. Go to the parent and paste. You could also add an animator fresh, and then you have to connect it to this cube animator that's sitting there. So I'll do that real quick. I'll remove it. I can just add component, add an animator. It needs to know which animator. Well, I happen to know it's called cube. This is looking through my whole project. I only have like 10 animators, not animations. And so I'm like, yeah, it's the cube one. But in any case, what happened is I moved the animator up to the root. And I can just remove the animator from the child. So the child has all like the rendering information. And there can be multiple children with each with their own render cubes and cylinders and whatever, however complicated you want your painted stroke to be. But here, the parent has a name, it has an animator, and from 1 to many children. So if I open up like multi-cubes, cube center, cube left, cube right, And now animated cube, or just single cube, has a child. That child is a renderer. In either case, they all just have an animator, one animator at the root. So I'm rebuilding my old prefab to be exactly like my new prefabs. Or just create new prefabs, create 3 of them, create them any case they want to animate children. I'm just fixing an old one so that it's in line with my new painted prefabs. But when I'm done, there's a few things I have to do. So I'm going to go hide these. This is my new adjusted prefab. There's now I have to make sure its animator is correct, and then I can drag it into my project. It's a new file, and I can connect that to my click detector script. So we have this cube animator. I got rid of this, changing the renderer component to it. Let me get rid of this sphere position. When it's yellow like that, it means there's nothing there for that animation to connect to. So you have cube bounce, cube rotate, cube position. And what's happening is this animation was playing at the root. I still want to keep this scaling information, this animation information, but really it needs to move down a level. And the easiest way to do that is I can just grab all these keys, copy them, and I can jump down and say, no, don't animate on the root scale. Go down to the child's transform, its scale, and just paste. And I can delete that. And I basically copied that scaling animation, that scaling information change, the animation information, all these keys, and I've copied it down a level into the child. And the point of that is I can click play, and I can still grab the parent and animate or change its scaling information, but the animation is now playing on the child. And so this is one step toward fixing the UI. Now when I spawn this prefab, I can actually adjust, change the parent's scaling information with code, and the child's information will be adjusted with the animation. So let's just say I like this. I fixed everything. I went through the animations and made sure I moved all the animation information down into the child, not at the parent. Or just created new animations just on the child, not on the parent. But either case, I rebuilt my prefab. Just drag it into your project. Here's my new prefab, rebuilt to be like the others. And then you go on your click detector script and you say, this is what I want to spawn instead of the old version. Now my updated fixed version is this cube animated 02, so I'm going to connect back to that. But that's how you can rebuild any old prefabs and then drag them back in to create new ones. My old one's still there. I'm just not referencing that with my click detector script anymore.
Okay, so you made a thinking notebook, and then you drag the old prefab into under the child, and then you remove the animator.
Move the animator up into the parent. And then I probably had to readjust the animations because the animations were playing at the root object. I got to move them down into the child. So first off, if you have any objects, any prefabs that are built already like this, you don't have to worry. So multi-cylinder, there's a transform and an animator. The rendered objects are underneath it, and I'm animating on them. You're good to go. If you have a situation like this, my old animated cube, where my renderer, I have to drag it in, cube animated, where notice there's no hierarchy, there's nothing underneath it. Everything's at the root. You either just need to build a new nested prefab, a new parent-child prefab to replace that one, or I just walked through how to like convert it into this parent-child relationship. When you do that, I'll go through it again. Make sure it's at position 0. And I actually already updated its animations, but we'll go through this again. Create a parent. An empty game object is going to act like its parent. Zero out its position information. Give it a name, new Q version 3 or whatever. Drag the old prefab underneath it. But now you're going to have to grab the animator, copy it, paste it at the root, remove the animator from the child. Now the structure of the prefab is correct. All the colliders and shaders and renderers are down into the child. The animator is now at the root. You just have to make sure the animations are now animating on the child and not on the root. So in this case, let's see if I add, yep, cube animated, which is the child. We're looking at the scale of it. So I already copied and pasted down, but what it originally probably looked at is if I take the scaling information and at the parent's transform, I paste it in and I delete the child, it probably looked like this. My animation is animating at the root transform. So I add property, go find the child, go find its transform, whatever property that I wish to apply the animations to. I copy the animation on the root, go down to the child's same property on its transform, paste it in, and delete the parent. And I just did it a few times. It's on the video now. So this is that's a complicated process. You can watch on the videos to do it. Or if you have prefabs that need to be updated like this, you could also just create whole new prefabs, create them in this nested structure, and just do the animations again. But in any case, here's how you get your prefabs fixed. And then when they're fixed, you drag them into your project so that they create a new file, a new version. And then you have to go to the click detector and say which prefabs are you actually spawning. And just double check that those need to be updated. And these are my 3 prefabs that are all built correctly now. There's just one I had to fix. So that now when I click play, oops, let me take a look at it. Now, this one I got to fix the animation on again. Down and paste it in and delete the parent. All right, you're good. Rotation looks good. Position looks good. Okay. All right. Go make sure that everything is connected to my click detector script. All right. 3 objects painted. They all, the size slider now impacts them all. So we're good because I rebuilt that one prefab.
pistons on the screen. Move the one input. That one doesn't move.
Okay. Well, this is like an hour lecture, and then I got 30 minutes after, so I'll troubleshoot your project then. Okay. So that's how to fix the cube. So, and that was this slider here, right? And then if you remember, I had like a lot of issues with all these color sliders and the animation speed. So to fix all that, I realized that I needed this idea of like a smart asset. They all now have this little script that actually records their data when they're first created. So to do that, all I did was create a new script. So under here, scripts, I just had a folder called Sprint4. But if you right click, create C# script, call it prefab data. Then you need to connect it onto your prefabs. So that's pretty straightforward. You can hunt for them. For example, cube animated. Let me go to one that doesn't have one. Let me strip this out. So this prefab file, I just changed it in the inspector. When you change the file, it's automatically updated. Whatever you do, your changes go right to file. So this is a prefab that if I click add component, and if I just type out prefab data, that's the script I just created, right? You can hunt for it, add it. Now I have prefab data script sitting at the root of my prefab. So the next major change we're going to have to do, I'll go to another one. For example, cube animated 02. Remember, I moved the renderer information, the collider, the shader, this renderer. I moved it into the child object. And if I go to the root, here's this should be zeroed out. Here's the transform, the animator, and I'll just remove this and say add component. Type out whatever the name of your script is, it'll find it, and just click add. Go to all your prefabs that you're going to want to spawn, add this script onto them. So now our structure of our prefab is that it needs a parent object, it needs a root object. By default, it's going to have a transform on it. It's going to have a nice name where you understand what it is. It's going to have an animator connected to it. And now it's going to have this prefab data script connected to it as a component.
So we add the prefab data script to
every prefab you wish to spawn. Yep. All prefabs are now going to record some initial information about themselves so that we can use it later. So for me, I have multi-cubes. Notice here, multi-cubes, animator, prefab data. I can open up, and the children underneath it just have colliders, renderers, shaders. Follow this convention, whether it has multi-objects or just a single object. Now all the root, besides an animator, it's going to have this prefab data script. All right. So on my click detector, I have this prefab, this one, and this one. And all of them now have a prefab data script on it. And if you don't, I just showed you how to add them. So let's look at that script now. So notice initial animation speed, 0. Initial color info, size, 0. So these are the default information. It's a very simple script, but it's going to give us some interesting attributes, some interesting features we can do. So all I did was I removed the start and update method, and I just added these two variables. These variables are public. I simplified things. There's no methods to get and set. I just made this very straightforward. We have some public variables that we're going to set when we first spawn copies of this prefab, and then we're going to reference them later. So I have a public float called initial anim speed. That's going to be set to whatever the animation speed of this instance of this prefab. And we have a list of type color called initial color info. So notice how the list kind of has those side brackets. Whenever we did get component and we had those little like angled brackets that said a component of what? Well, I want to grab the transform, the animator. I want to grab the renderer. And sometimes we, in this situation, we're going to grab this script. So you've seen these angled brackets before. So this is a new type of variable of type list. So a list is a type of an array. It's going to be a collection of elements. So just like the drop-down user interface it's called what's called an enumeration, and no matter how many entries you added to it with names that are easily recognizable to a user, behind the scenes, all those elements were referenced by a number. So element 0, element 1, element 2. And that's how we were setting our shape integer to know which type of shape to generate, prefab to instantiate. So in this case, we have a list of type color. So color is a variable. It's a data structure. It's of type, there's 4 floats in it. Usually it's RGBA, but 4 floats and then all these methods, and it's a more complicated data structure of type color. You can have lists of any type of data structure, any type of variable. You can have lists of floats and ints and bools and what have you. So a list is just going to be a collection of elements, very similar to how an array is, but it abstracts some of the functionality of the array away from you. So it's actually easier for you, the developer, to use a list, but it's adding a little bit of overhead. So, and this is a very simple project, it doesn't matter, but an array is a more, I'll say it's a more of a low-level data structure where you have more manual control over it and it's lighter memory-wise, but a list kind of, it automates a lot more of the features of an array for you, so you can do a lot more faster with less code. You're just leaving a heavier memory footprint on your computer, on your CPU, and when you're running your app. So in this case, and at the end of this class, I wanted to introduce the idea of an array or a list. It's kind of building off the idea of an enumeration or a list or a collection of elements. And the reason we're doing this is because when we spawn these prefabs, we want to record all this initial color information, but we don't know how many children game objects are underneath. Sometimes there's one. In my situation, my prefabs have 1 child that can be rendered up to, and 3. I have multi-cube, multi-cylinder, which have 3 children, which are renderable. And I have animated cube, which has 1 child, which is renderable. And some of you guys have 6, 7, 8 renderable child game objects underneath your root prefab. So I'm going to use something like in a list where it's very easy to feed in an unknown number of elements. So for me, it'll be between 1 and 3. And for you, it'll be however range of children game objects you have under your prefabs. So a list, a collection of colored data structures. Now I'm going to click play and just let it run, and I'm going to click on a few of my prefabs to show you what the information looks like before I show you how I set this information with code. So I'm going to click play. I got to get out and maximize on play to do this because I have to look at my hierarchy. Turn off time destroy. I'm going to paint some of this, paint some of that, paint some of this. 3 different paint strokes. Underneath my click detector, I'm going to click on 1. If I press the F key, it's the first cube that got spawned. So it's right up here. All right. Go down. Here's the prefab data. It's got a 1 in the animation float. That was the animation speed that was set to it. Its list is of size 1. 1 color element. This is the element. This type of pink color. So if I open up and drill down to its child, the actual object that gets rendered, I can see here's its shader color. it's the exact same color information. So whatever this color, this pink color that was given to its child, it was also recorded up here at the root, along with just the animation speed of the whole object. So if I click down onto the next one, press the F key, it's this little blue cube. He's kind of sitting on other objects. He's hard to see. You can't even see it at the game camera. But the parent recorded, it has one color to record, and it's of this blue type. And if I click the child, indeed, that's the blue color. So they're all going to have an animation speed of 1 because I didn't mess around with this, and it's not variable, but it's not random. But I'll show that later on. But for now, let's just look at the fact. Let me click on a multi-cube, press the F key. Here it is. It looks like we got a dark purple, a light purple, pink, and a red. And then here's the 3. In this case, we have 3 elements to our list because there's 3 children that have renders, all with different color information. The dark purple, this pink, and this red. They have a 4th attribute, the alpha, and if you can see here, it's half white, half black, meaning half. And I'm just setting all the opacity to half because my slider's at a half. It's not being randomized. I open up multi-cube, cube center, open up its shader. It's got this dark purple. Next one, it's got this hot pink. Next one, it's got the red. Those are the 3 colors of the children, and they're stored here. And if I would move down the list and keep, you would get the point. Yeah, I can move down into multi-cylinders, press the F key. They're moving kind of fast, but it looks like I got a blue, a pink, and a purple, and here they are. And if I open them up, that's the color information of the capsules. Okay? So, let me clear them out. I'm going to click on randomize speed. I'm going to just click on a cube just to make this simple. But I'm going to paint a bunch of cubes. They're all moving at different speeds. Let's look through them. Initial animation speed, 0.4569, 0.1975, 0.03. So if I press the F key on this one, he is barely moving. Just barely moving. And then if I click on one that's got a high speed, 0.75, click on that one. You can see how quickly he's moving. Right? They all got randomized animation speeds assigned to them when they were created, and I stored that information in this script at the root. It's going to make my life very easy with doing the UI fixes. So at this point, do you understand what this information is connected to, and I'm going to show you how I recorded it? All right. So if I click on one of these, notice that they default out to their default values. Floats default to 0, lists default out to 0 size, 0 elements. So where am I making use of this? All right, here we are in the update loop. This is when the user left clicks. We're going to spawn the object. Now, this is where the object gets spawned, instantiated. This is where we kind of morph the size of it based on where the distance of the last stroke was. And here's the renderer. This is kind of getting obsolete. By next week, I'll probably comment this all out. This is saying if there's a render at the root level, we're going to do this stuff. Well, now that we've updated all our prefabs where only children can have renderers, only this section of code is most important, is actually doing something now. So we go through each child of the paint stroke of the prefab. Does that child have a render? They all do, but I'm just doing a safety check just in case, maybe a developer made one that didn't. We're going to randomize the color. We set the opacity strength to 0.5. So 4 floats in our color data structure, put it in our variable of type color. It's like a reference, it's a holder container. Then we're going to assign it to the color variable of our material of this object, or this child of our painted object, this certain child that we're on in this for each loop. And then this is new. Well, after we do that, we're going to go to the root primitive, references the root of this prefab. We're going to go get component. What component are we going to get? Not an animator, not a transform. We're going to get the prefab data script. Get component, angle brackets, go find the prefab data. Once we do that, in this case, we're going to go get the list of colors. We call it initial color info. Once we have that list of colors, we're going to use this method called add. It just adds a new element. What are we adding? I want to add this painted object color, which is a reference to our newly set up color variable for this child. I want you to add that color variable to this list. So when you're dealing with arrays, you have to kind of manually go through the array, find the element, add in that new element's information. Here, since we're using lists, I can just say add this or remove this. I don't need to micromanage my array or my list. I don't need to micromanage it like I would an array. So it kind of simplifies things. You're using a more complicated data structure called a list, and all you have to do is call the add method. Add an element for you. Of this case, it has to be of type color. So that should kind of give you an indication that maybe get component is kind of running like a list, and you can pass in you can search for any type of components within it. It's a more generalized list. But in any case, we're adding the color to our prefab list of colors on our prefab data script of this actual prefab that we just spawned. And then we go through and we set up whatever its emission color is, and we add that. I don't store that information because the emission color is based completely off the color, just adjusted a little bit by this emission strength. But the RGB of emission color comes straight from our color variable or color data structure. So I only need to remember that. So for each child, we go through and add a color to our list. That's why the list will end up being the same size of the number of children. I don't even need to know. You can feed in any prefab here as long as it's in this little structure we made. Doesn't matter how many children it has. It'll just add all that color information to my list. I don't need to worry about it. All right. So the only information we have to add now is our animation speed when we first spawn an object. So now we're just doing a check, just making sure that the root of our prefab has an animator. If its anim type is random, we're doing some stuff here. We're setting the integer, the state, the animation state that should be on our animator. We're doing some checks if we should be randomizing the speed, blah, blah, blah. And then this is new. So again, we're all done. We figured out our animation speed. Okay, go to the primitive, go get its get component prefab data. Go get the float. It's public. I can just grab the float, the initial anim speed, and set it equal to this speed factor that we just figured out here. You know, it might get randomized, this and that. We might do some, have to do a roll. So at the end of the day, I just say, just go back to its animator, go find its speed value that you ended up setting, and go record that in our prefab data script. And that's it. Basically, those two lines, this one recording the state of our speed, and this one recording the state of each child's color. And that's how I'm populating this prefab data script. And you saw me spawn the painted objects. You saw that they were actually recording their information. So I'm going to click play. I don't think I changed the script, but maybe I did. Maybe it's the recompile. All right, turn off time, destroy, paint some objects. Now I'm just going to grab one. I'm going to turn off the animation speed, press the F key. Okay, here's the first object I painted, this green cube. Here's its initial color information recorded. Now notice I can pull out the green, and it pulls out the green from everything. And this one is like a dark purple now. And I go down to its child, the actual renderer, and it's purple. I can click on it, it's purple. But it still remembers the original state. So that's why I can pull out all the color information, get them into grayscale, all blacks. I can remove all color information, and I can still bring it all back. It remembers all of that color information. And I just showed you here, prefab data, it's still green. Even if I pull out everything, all color, and it's now black, it still remembers its initial color. So to prove that it works, now we can go into the script and see how we, first off, let me do change animation speed. This is simpler. So the only change to this script is this section here. Instead of just passing in the float from the slider and setting our animator's speed directly to that, we're now saying go to the prefab data, go find the initial animation speed, and multiply that by this temp float. So the temp float can go from 0 to 2. You can set it to 3, 4, 5, meaning 3 times faster, 4 times faster, and you can even go negative. You can even reverse the speed of the animations. But in any case, I'm going from 0 to 2. And that's being multiplied by the initial animation speed. So it's kind of a scaling factor. It always remember what this initial seed, this initial animation speed was, the seed to start it off. So if the seed was 50.5, it's only supposed to be moving at half speed. It'll go from 0 to 0.5 times 1. So when the slider goes all the way to 1, we're only ramping up to the original speed of 0.5. If the original speed was 2, when we ramp, the slider goes to 2. So if we pull all the slider to 2, that one that had a 0.5, it's going to double up. And double speed for it means go to speed factor 1. If it initially start at 2, we ramp it down to 0, it goes down to 0. We ramp it all the way up to times 2, it'll go up to 4. It'll go 2 times as quickly as it originally started. So that's why I can paint out a bunch, randomize the speed, and when I play with the speed factor, everything can stop, but I didn't lose all the information. And when I ramp it up to 2, they're all relative to their speed factor. It's just everything is moving twice as fast, but they're still offset from each other. And then 1 is back to where their all original was set to. And then half, everything's at half speed. That's why there's an X. Now it's a speed factor. So I can paint them all again. You can kind of see their relative differences, and then I can ramp it up, and they're still relatively all the same because they're multiplying this slider by whatever their initial speed value is, which is right here. Current speed equals initial speed times this slider float that the user's dragging. So once that idea is you're comfortable with it, how to change or update the color information is just the same idea, just a little bit more complicated. So here you go, change red. Again, this is kind of obsolete now because this is looking at the root. So it's only called the child because it's the child of our click detector script at this state. So when we say child, we're referencing our root of our prefab that has been spawned and is now a child of the click detector script. So this code actually will always not run because there's no render at the root. And this is the central area of it. Go through each grandchild, which is technically a child of our root, see if it has a render, which they all do. And then what we do is, okay, go to the child, which is the root. You know that there's a prefab data script there. Go get the initial color information of which color, though. Which element should we pull out of our list? And we take its red, its R value, and multiply it by temp. We update our variable and pass it back to the renderer of that object that we got it from. So before I explain the child count, just note that we're taking our R color from the initial color information, multiplying it by the temp, and passing it back to our shader, to our renderer. So remember, the slider can go from 0 to 1, means if the person is dragging the red slider, if they drag it down to 0, it means we're pulling all of the red out. But if we pull the R slider all the way back to 1, what we're really saying is whatever the original red value is, multiply it by 1. Or give us back our original red value, which can be anywhere from 0 to 1. If you pull the slider to 0.5, you're saying give me half of the original red value that was given to this child object of this prefab. Very similar to the animation speed. And we do the same for blue and green when we play with the slider. So give me a relative value off of the initial red value, or whatever the color value is. Okay? But remember, initial color info is a list. That list is just as big as the number of children. So how do we know which child we're at? Well, we have to be going through a for each loop of each child. So I'm basically turning the for each loop into a for loop. Just like the for each loop abstracts away, it hides details of how to run a for loop, where a for loop is more manual. There's more work put in to build it up. We didn't really go into a for loop in this class. We did the simple version. We did the for each loop. The list is like the for each loop, and the array is like the for loop. So for me to basically convert the for each loop into a for loop, I have an integer. I create an integer, local, called child count, set it equal to 0 before we even go into this for each loop. So if there's no children at all, we dump out, we don't do anything, doesn't matter. If there's one child, we go through, child count is set equal to 0. So go find element 0 of our list of colors. Element 0 happens to mean the first element in our list. So we recorded that information when we first spawned it the same way that we're recording back. So we know that whatever way that we set up, order that we set up the elements in the list, we can go and retrieve them the same way. So how do we retrieve? Well, we don't use an add method. We use this square brackets. So in the initial color info list, we say, which element do you wish to get? It's going to be an integer, and that integer needs to be surrounded by these square brackets. It's like it's shift up in the top right corner. There's these two characters. So in this case, I'm saying child count is 0. Go get the red data member of the first color element of this list, which lives at the root of my prefab. Once we have the R data member, the R variable, which is just a float for red, multiply it by temp, whatever they're dragging the slider to, meaning fully red of whatever red was to fully off of whatever red was, and then we slip it back in, send it, we set our color. We change the red variable, now pass that color information back to that renderable object, which happens to be a child of possibly many of our painted prefab. So the next step is I'm setting the emission as well. So whenever we change the color, the emission color kind of comes along for the ride. It's just clamped down on a little bit on the emission strength. So once we figured out, in this case, we figured out whatever red is. Now we changed painted object color. And they say, okay, create a new color, base it off painted object color red, multiply it by emission strength, take in green, multiply it by emission strength, take in blue, multiply it by emission strength. Now I have my new painted object emission color. It's another variable. And I'm passing that into my emission color of my material. So I'm setting both the color and the emission color whenever I'm dragging the R, the G, or the B.
You added those 3 lines.
They should have already existed. Did this not exist in your script right now? These don't exist? Huh? Okay. So, yeah, this is a variable that already existed.
No,
I'm grabbing the color. I'm changing the R value, multiplying by temp. And then I could almost change this to here. Maybe it makes more sense if I do this and then I do this. So once I found out what the new R, the new value of this R float, I go and set it back to the color variable of my renderer. And then, yeah, now I'm going to move over into updating my emission color. So I guess I did this too. I think maybe I realized that the emission color, it was looking odd. I think when I was messing with colors and then the emission color was the original, the emission color needs to come along with the color to make it look correct. So to do that, I use this variable which already existed called painted object emission and set it equal to a new color based off the R value of this new color multiplied by emission strength, because emission strength is this here, this how strong should it be glowing on a scale of 0 to 1. Take in the green, multiply by emission strength, and the blue. For emission, we don't worry about alpha. We're just setting RGB. We're passing it into this reference variable. And then we're setting, now we're setting the color on the material of the render, but it's the emission color variable and not the color. And then we're done. And every time we go through this loop, I increment child count. So the first time we go through, child count is 0. Second time it's 1. Third time it's 2, and so on. And that child count is how I'm keeping track of which element of my color list should I be referencing. And that child count integer increments every time I go through this for each loop. All right, so I can rebuild this for each loop into a for loop now since I'm incrementing an integer, but I'll just leave it like this. Yes, for G and B. So G, same thing. We're going to prefab, going to initial color info. Which element do we grab? That's based on child count, based on which iteration of our for each loop. But now I'm pulling out the original G value, the original green value, not the red. And then everything else is the same. Blue, all we're doing is pulling out the original B value, blue value. Everything else is the same.
And we haven't changed the emission strength of color?
Yeah, so change emission strength. You can check your script. I don't know if I had to change this, but I pulled in the current color information and then took its RGB multiplied by whatever this temp coming in from the slider, and then I set the emission color to that. Was that what it was original? Yeah, I don't think I had to do this then. So this seems to be the same. And then opacity is the same, because opacity, you don't need a memory. Opacity is just alpha, 0 to 1. I'm not doing anything complicated with it. And the others, I had to have a memory. I had to create a smarter prefab that remembered some stuff. For the alpha, for the opacity, I didn't have to do that. Just the slider coming in is a slider going to its alpha channel. So that is it. So at the end of the day, I had to create a prefab data script, connect that to all my prefabs. I was aware of it when I was spawning objects. And here, I'm recording, adding a color element to my color list for every child when I spawn a prefab. And here, I take whatever my animation speed that I figured out, I put that into my prefab data initial anim speed. That's it for setting it initially. And then, yes, for change animation speed, I modified it to now read in this initial animation speed, multiply it by this slider float. And for change RGB, I read in I took in the color that it's currently at, and then for whatever color slider, for example R, I just changed that, figured out what the initial coloring of R, multiplied it by this temp, set it, and then went and updated the emission color as well. And then did that for R and G and B. And now my whole user interface works. And I fixed the prefab. I have one old prefab that was out of date, that single cube prefab. And the structure of a prefab I'm going with now is that there has to be a parent and a child, even if there's just one renderable object. The parent must have the animator and the prefab data script, and you can have as many children as you want, and they will all have their own renderer and collider. They just cannot have animators or prefab data. And if you follow that convention, you should be able to have all paint strokes function, and every part of your user interface now works. All information is remembered, and I could just stress test my user interface, make sure every feature that I'm exposing to the user cannot be broken, no matter how they use it. Okay, and next week, I'm just going to cover this, randomizing the spawn type and the spawn time. And that will be a much lighter class. So we're kind of ramping down, wrapping up. And remember now we have our final exam in 2 weeks. So, since we're ramping down, we only have 1 lecture video a week. You know, if any of these topics you forget about, click into here. There's a series of videos for each. Or go back to my old lecture videos. But for now, since we were just spending a lot of time with the code, I mean, I was in Unity a lot. There's different tabs and windows. We were dealing with game objects and prefabs. We were working within one scene that we build. The project is like where all the external files are. The hierarchy is like all of our temporary, we're building up the application information. We have this idea of children and parents. Everything has a transform. Every object has components on it. You can create your own with scripts, right? And now we did a lot more scripting. So we have this idea of variables. You were introduced to floats and integers, booleans, strings. Now we have vector 3s and 4s, which are a series of floats. This idea of a series or a collection brought us to enumeration. So like the UI dropdown, which you can call its elements anything you want, but behind the scenes, it's really just a collection of integers. That brings us to this idea of like arrays. So enumerations, you can think of like now arrays, and what we just did with lists. So you can add or remove. You can go and use the square brackets to check different elements within it. And each element can have variables, data members. It can have methods that you can call. They might be private or public. There's rationales for each. You can have such thing as global or local variables. Local were declared within a method and will be destroyed when that method ends. Quaternions, the version of a data structure that's used for rotation. The color data structures are used a lot with the renderer. So you can do get components to get different parts of a game object. We had if statements, if else statements. We had switch statements. Different types of loops. We used for each and while, but there's also do while and for. And it depends what your goal is, what you're going to use. It's idea of different methods or containerized code that you can call. Classes, other big code bases that you can include using the using statement to pull in other libraries. I think we have this. You can pull in variables that are more like references. So this idea of like very simple data structures like integers, floats, and bools. The variable actually is referencing the value of it. You can have this idea of that variables are also kind of like references or links or pointers, where they're pointing to more complicated data structures that within them might have variables and might have methods, but we're kind of just pointing to them. We're not referencing the whole thing. And I think I'm good. I'm going to we're going to talk more about this next class. But I just covered topics ideas you should be familiar with now, that toward the end of the class, that if I ask you something, say what, just explain to me the difference between a class and a method. Give me 2 sentences. Tell me what the difference between a class and a method. You should be comfortable with something like that.
Are there any questions or like other notes like writing code that would let you rotate an object? Something like that?
Oh, so it's a pseudocode problem? No, I'm not going to have anything like that. I might show you a snip. I was definitely going to show you snippets of code and be like, what?
Say like what they are.
What's that?
You mean you're gonna put like a code and then we're gonna say explain what it is?
Yeah, or like there's going to be like a section of a code and there's going to be like A, B, C, D pointing at different things and like tell me which one is the private integer, or tell me which one is the method call and pick A, B, C, or D of a section of a code. All right, so I am just going to briefly jump back to the project that you're going to have a full completed build in 2 weeks. That's like this. Have a little project description. Here's the points you want to knock out. And then what's unique this time is instead of user flows, take a screenshot of your code area that you wish to explain back to me, explaining the functionality of the code, what it's doing, explaining a bug you fixed, explaining something you really liked about it, just letting me know that you're able to actually understand what your code is doing, some part of it. Then take another screenshot and do it again. 2 sections of your code. Just a few lines, just something that's you can actually explain. All right? Any questions?